Hi, everyone. Welcome to the IARS Virtual Education webinar, and today's presentation is on precision medical education. I want to comment that this webinar has received no commercial support. Now, I've got a couple of housekeeping items, and the first is in case you missed the 2025 annual meeting. The on-demand recordings are available now on the IARS website, and also I want to remind everyone about the 2026 annual meeting in Montreal, Canada. That should be an excellent meeting, and I hope you all can attend. After this webinar, please feel welcome to join the conversation, and there's a couple ways that you can do that. You can access prior IRS webinars on the website, and I've listed the website here if you wanted to look at those. And also, we're going to give you an opportunity to do Q&A for this particular webinar. Now, I'm going to ask you that we're going to collect all of the questions that you have, and you should access those by clicking on your Q&A tab and submit your questions. And then we will be distributing those questions out to the various panelists at the end of the webinar. So we're going to hold all questions until the end of the webinar, so we won't be answering any of those. Of course, we may get more questions than we can answer, and I encourage everybody to reach out to us. All of the panelists are more than welcome to answer questions, or more than happy to answer questions when we're done. All right, so let's get started. As I mentioned, today's topic is precision medical education and anesthesia, harnessing data to advance learning in the digital era, and I'm excited to introduce our panelists. Each panelist will only have 10 minutes to give their presentation. So our first speaker will be Dr. McKenzie Hollon, and Dr. Hollon is a cardiothoracic anesthesiologist at Emory University. She's also the vice chair of education there, and she's a founding member of the Anesthesia Group on Education Technology, and that's a consortium of universities working on precision medical education. And she's also enrolled in a master's in education program at Johns Hopkins University. Our second speaker will be Dr. Gopawani, Dr. Sumeet Gopawani. And he's going to follow up Dr. Hollon with a discussion of the importance of using data to create a unified view of the learner. Dr. Gopawani is an associate professor at Georgetown University, where he's also the director of pediatric anesthesia. Our third speaker is going to be Dr. Greg Booth, and Dr. Booth will discuss the potential role of artificial intelligence in precision medical education. Dr. Booth is the program director at the Portsmouth Naval Medical Center Anesthesiology Residency, and of course, he's an associate professor at the Uniform Health Sciences University. He serves on the ABA Technology Task Force and is also a founding member of the Anesthesia Group on Research and Education Technology. Our final speaker is going to be Dr. Khaled Kitana, and Dr. Kitana is going to be providing us with an overview of a current effort to bring a precision medical education app out to all of the anesthesia departments. Dr. Kitana has completed his medical training as well as a couple of years in anesthesia residency in the West Bank in Palestine at Rafidia Hospital, and he is currently going to be attending the University of North Carolina's anesthesia residency program as soon as he's able to get his visa approved. So without any further ado, I'm going to turn it over to Dr. Hollon to talk to us about what actually is precision medical education.
Welcome to this IARS virtual education session on precision medical education. My name is McKenzie Hollon, and I am the Vice Chair for Education for the Department of Anesthesiology at Emory University in Atlanta, and I have no relevant disclosures for this talk. In this talk, we will briefly touch on what is precision medical education, what existing problems do we have within our medical education systems that we're aiming to solve with the development of these tools, and briefly describe some current examples of precision medical education tools. Let's start off by talking about what is precision medical education. It's a systematic approach that integrates longitudinal data, such as from attending assessments, from a resident's clinical performance, or data from an electronic medical record, with an analytical process to generate some type of actionable insight that can be used to tailor or adjust the individual's educational activities. The aim of precision education is to maximize both the efficiency and the effectiveness of learning for physicians, by personalizing the way they are taught, the way they are assessed, and how they are coached. It can be described through a P4 framework, which has 4 different adjectives, all starting with a P, kind of making it a little bit easy to remember. So the first one is proactive, and this means that learners are provided with timely data and guidance which support an anticipatory adjustment. It's personalized, which means the interventions are customized to each individual's goals and progress. It's participatory, meaning that all learners are engaged as full partners, and it emphasizes agency in their decision making and in their learning journey. And it's predictive. It uses data to forecast learning needs and system level outcomes, which can drive improved patient care. So this slide includes a graphic that illustrates the operational cycle to give you an example understanding of how precision medical education efforts can work in practice. So it's anchored by data. Data inputs are collected continuously, and this data can come from any type of learning activities, whether it's a quiz bank or a simulation. Data can come from clinical encounters or assessments of learners by their attendings, and data can also come from the medical record. So that could include something that lets you understand what experiences the learner had, what type of patients they cared for, as well as patient outcomes. This data is then all harnessed, and technology-enabled analytics, including those powered by AI tools, can generate some insights that can provide an understanding of the current state of the learner. This helps illustrate where the learner is and what's currently happening with them. Then, educators and learners can use this synthesized information, the insights, to help direct the learning journey and see what's needed next. So for example, if a knowledge gap is identified, then tailored educational content could be delivered to that learner on that gap. Or if a performance issue is uncovered, then the learner could receive personalized coaching that can be done in a timely manner to have the best impact. After an intervention is delivered, then outcomes are assessed at different levels. So whether that's the individual level, the program level, or organizational level. And then after outcomes are assessed, the cycle repeats, and this allows it to be adapted and continuously improved. Now let's quickly discuss what are the pervasive problems in medical education training programs that we're aiming to address. The first one is lack of individualization. We all know that traditional medical education has relied on generic one-size-fits-all curricula, and this makes it difficult to address each learner's unique background, where they are at the time, how they're progressing in their competencies, what are their unique gaps or learning styles. We also have a problem with feedback. Most programs have limited actionable feedback in their existing systems. Either the feedback is inadequate, such as read more, or due to privacy concerns, it can be delayed. And this means that learners really can miss the opportunity to correct their course or to reinforce their strengths at the right moment. We deal with a lot of inconsistency in assessment standards, meaning there's a ton of variability in how assessments are conducted and interpreted across institutions. This makes it hard to apply evaluations of the learner and of educational outcomes. And then we may also be dealing with quite a bit of insufficient alignment of our education with actual clinical practice. So the things we're teaching may fail to keep pace with the rapidly evolving clinical knowledge, and this can make a mismatch for knowledge and competency. And then we all know that we're collecting a lot of data, but most programs are unable to leverage this data yet. So systems that help us use data to inform us. And then finally, an important one that I think will really make a difference in our learners' engagement is current systems have limited learner agency, and a lot of precision systems are aiming to drive that learner involvement and buy-in so that they can direct and adjust their own educational journey. Okay, so how can precision education tools help address these problems? Well, as we described in the cycle, it really promotes individualized learning. The data collected from diverse sources gives a unique picture of the trainee, and that insight helps tailor the educational approach, kind of smoothing out competency gaps and hopefully improving the learner's outcome. All this real-time data collection and analysis can give timely and actionable feedback, things that can be customized, and this can help boost the learner's confidence. Standardizing and enhancing assessment with technology and with minimized variability can help a more fair and more transparent evaluation systems exist, which can help learners thrive a little bit better. And then finally, giving the flexible pathways and personalized resources can empower learners to direct their journey and enhance their engagement with their own education. So finally, I'm going to quickly share some current examples of precision applications in undergraduate and graduate medical education. So one that you may be familiar with is a learning engagement dashboard, and these were first popularized by organizations like the Khan Academy, and this is a visual tool that aggregates and displays multiple indicators about a learner's activities and their progress and how they interact with the educational environment. These are typically updated in real time, and they're able to synthesize a good deal of complex data, such as how frequently they log in to quiz banks, how much they participate in activities, what content they access, what type of peer interactions or feedback they've received, and translate this data into more of a clear visualization that can help the learner themselves and the educators monitor and enhance their learning journey. Another example of a precision medical education application are advanced assessment tools such as resident-sensitive quality metrics and technology-enhanced skills measurements. And both of these can provide more of a personalized, data-driven evaluation of a learner performance. Resident-sensitive quality metrics link individual trainee actions with clinical outcomes, and these allow assessment of how a resident's care can directly affect patient safety and quality. And this can help educators align education with real-world clinical impact. Technology-enhanced skills measurements would be something like a simulation-based assessment or motion tracking tools, and these objectively quantify the competence or the clinical reasoning with pretty high fidelity and the ability to give repeated feedback. So tools like these enable continuous, precise, and a contextualized assessment of learners, and this can help drive targeted interventions. Another example that you may be familiar with are adaptive quiz banks. And these are quiz banks that dynamically adjust question difficulty and content based on the learner's responses. This allows more of a personalized learning pathway, targeting the individual's knowledge gaps and reinforcing mastery. Other examples are automated coaching or recommender engines that deliver educational content based on identified learning gaps. So in closing, precision education tools exist to help personalize the learning experience for our medical trainees, to help enhance the effectiveness of all these educational efforts and ultimately their own learning outcomes. And these tools are really a method to address some of our pervasive issues in medical education and to evolve and improve our efforts and hopefully have better learning outcomes for our trainees as well as for ultimately our patients. And then finally, data is the central driver of PME tools. All of these tools utilize data, so learning how to collect it and leverage it is really our challenge in this space. Thanks for listening.
Thanks, Dr. Hollon. And now we'll go to Dr. Dr. Gopawani.
Hi, my name is Sumeet Gopawani, and today I'm going to be talking about the representation of learner data as it relates to precision medical education systems. I have no financial relationships or commercial interests to disclose. So what would a unified view of learner level data look like? It's important to understand here that, first of all, we're not talking about program level data. So we could be looking at knowledge or procedures that are completed at a program level. We could look at educational interventions and how they impact the outcomes of a cohort of residents, or impact the knowledge, the outcomes within a program. But we're looking at the individual learner here. And so looking at that individual learner and their portfolio, the question is, the first question is going to be, what should they know? What is the knowledge that we want them to have, and what do they know and what don't they know? So what do they need to learn? What have their clinical experiences been? What have they seen in the last month, in the last year? And what are their clinical experiences going to be? What's upcoming for them? What are they going to see tomorrow or in the next month? And what can we teach them about? What is the assessment of the learner's skills? What can they do? What can't they do? And how are we assessing it? And then what do we know about the learner's patient outcomes? We feel like if we had this information, what do they know? What have their experiences been? What are their skills? What are their outcomes? we'd have kind of a secret sauce. We could put this together and have a pretty good picture of where this learner is at. So actually, a lot of this data is out there. We have a ton of information about our learners. The problem is that this data is fragmented. It lives in silos. It comes in different structures. So looking at that knowledge component, we know the ABA has data, right? So they're conducting board exams, in-training exams, as a knowledge assessment. And then the residents spend a lot of time now, at least ours, doing quiz banks. And the quiz banks have a lot of knowledge assessment data. Looking at experiences, a lot of that is going to come from the EHR, and we'll talk about that in more detail. But the residents' experiences could also be in ACGME case logs. They could be in personal case logs or maybe kept at the program level. Their skills could be within the ACGME milestones, and they could be in some proprietary competency assessment system that the program is using. And the outcomes could be in national databases like MPOG or NACOR, but a lot of the outcomes data is also going to be kept locally in the QI or patient safety event reporting system. And so we see there's a lot of data sources that we can try to access. So you've heard me about Target, and in that educational consortium, Glenn has really led us in developing a digital representation of the learner using Bloom's taxonomy, where the largest domain is knowledge, and within that experience, and within that skills and outcomes. Okay, so knowledge is in many ways from a data standpoint the most straightforward. As we talked about, we think the ABA has data. These proprietary quiz banks have data, and even with some of our learners, we could go back to and look at like NBME data. And some of these are actually like things like a quiz bank, maybe using that knowledge assessment in real time to impact the next questions that are given. So we can look at the number of assessments, the percentage that are correct, the timing of assessments, and use this to represent our learners' knowledge. In terms of experience, the big treasure trove is going to be that electronic health record. So, and it's very powerful. If we can get into the electronic health record, we can pull out for an individual learner, say, what have they all on a monthly basis? What have they seen? We can look at surgery CPT codes, anesthesia CPT codes, patient ASA scores, patient demographics, diagnosis codes, right? So all of this information to understand what this resident has seen, what cases they've done, and then we can keep that into some sort of data warehouse and keep this profile of this resident. And if we're very nimble at getting into the EHR, if we can get in there every night, maybe we can figure out what this resident is assigned to do tomorrow. And we can provide them learning opportunities based on tomorrow's cases, tomorrow's patients' problems in a very just-in-time, real-time way. Many of the competencies or skills may also come from the EHR, particularly a patient's procedural skills. So things like nerve blocks or airway management, vascular access. We can get that out in procedure notes, and also potentially some natural language processing of free text. But there's also going to be non-technical skills, right? Things like conflict resolution, crisis management, interpersonal skills. Those competencies are going to come from things like 360 evaluations, faculty evaluations, maybe OSCEs, simulations, mock oral boards. We may not be able to access all of those things, but if a program is using a system like New Innovations or My Tip Report, a major competency assessment system, we can potentially get access to that and evaluate non-technical skills in that way. Outcomes, as we said, there are databases that are deeply looking at outcomes already. Things like MPOG and NACOR have a lot of that data, and a lot of it also can come from the EHR. And so that may involve natural language processing of postoperative notes. It may involve access to QA/QI, right, and incident reports or patient safety management reports. But we think that outcome data is critical, because if we know that a resident has experienced a patient who experiences postoperative visual loss or postoperative MI, that resident is potentially very primed to learn about those topics, and so we should access that. So building a representative model, the ABA content outline is a good starting place, but it's really insufficient. It may represent some very basic concepts well, things like the alveolar gas equation, but it also has some very general titles like otolaryngologic surgery, which really need to be subdivided into many subnodes. Um, and so we took the ABA content outline as a starting point, as well as three major textbooks, and started with some high level nodes, things like anatomy and physiology, pharmacology, anesthesia management procedures, technical skills, non-technical skills, surgical procedures, medical conditions, and we broke those down into many hundreds of child nodes and subnodes, and really about 2,800 concepts in a hierarchical taxonomy to create a representation of the learner. That's not the only way it could have been done. I mean, there are other options. There's ontologies which have nodes and include many more relationships between nodes. There's knowledge graphs which have nodes and edges connecting them with different relationships. But we felt like that hierarchical taxonomy was the most straightforward, starting with the ABA content outline to develop that representation. So what are the challenges with data representation? So how do we evaluate learner assessments over time, whether that be knowledge or experience? Do we look at what someone has done in the last few months, or as they learn, how do we deal with the time constant of that? How do we roll up data in a meaningful way? If we take all these subnodes and we know how many of each procedure a resident has done, or how many of each type of block, how do we roll that up and say, a resident is competent in regional anesthesia, or a resident is competent in neurosurgery? And so rolling all that data up to make meaningful assessments presents a challenge. But the biggest challenge is the integration of different systems. Standardized data structures are really critical to interoperability and data integration across systems, across the boundaries of systems and organizations. We already have some standard definitions like HL7 and FHIR, but really each entity in medical education in the healthcare system is basically functioning independently, and they're often very resistant to share data. And there's a number of reasons to that. I mean, it's to protect individuals, to protect organizations, but also because of posture related to IP, tech transfer, and just risk in general. And our group has certainly found that scaling a PME system across institutions is challenging, if not prohibitive, because of these boundaries. And we've also learned because of that the critical importance in partnering with clinical informatics, as well as our EHR backend team to really develop these new technologies. But our hope is that in the future, collaborating institutions will be able to capitalize on what is the inherent scalability of this kind of technology once these barriers are overcome. Thank you.
All right, thanks, Dr. Gopawani. Now we're going to move to Dr. Booth, who's going to talk to us about artificial intelligence and precision medical education.
All right, sorry, I'm trying to pull up the view so you can see me here. Tracy, are you able to change my video? No worries if you're not able to. Thank you.
And Greg, you might want to put that in presenter mode.
Gotcha. All right. Thanks, everybody, and good afternoon. So again, Greg Booth, and we'll talking about AI and precision medical education. The previous presentations, a little bit maybe high level, how to integrate all this together. I'm going to focus a little bit more on the specific applications, maybe how you would handle one subset of those problems. I have no disclosures, and I will be talking about any off-label or investigational drug use. Standard disclaimers, I'm active duty, so these things are my opinions, don't represent the government, and there's some copyright disclaimers there. All right, so objectives, describe how AI can manage disparate data types, appreciate the strengths and limitations of large language models, similarly do that for small language models, and finally give some examples of applications of AI in precision medical education. So a little bit about data types. There's two kind of primary types. You probably got a sense of this with the previous presentation, but the first type is structured. Generally speaking, that's things that fit nicely into a spreadsheet. There's generally some sort of order or simple way to organize it. It tends to be well suited for traditional statistics. Unstructured, the second type, that's basically everything else. And probably 95+% of data these days is unstructured. Things like language, whether it's written or spoken, image, video. And those are the prime targets for AI techniques and really where most AI models nowadays are focusing their attention. That's where you get the biggest bang for your buck. A lot of information is embedded in that data. And it's hard to extract. So how can we do that? How can we extract some data, some useful information from that data? Probably the most important advancement in AI for the last 10 years is this concept of embedding. And so the idea is that you have some piece of data, some collection of data, and you convert that data into some higher mathematical representation. So if that's language, you can convert that language into some mathematical model and then manipulate it in some alternate kind of space and then use that for some useful outcome. As AI systems learn, they kind of update their parameters. And as that happens, you're basically modifying that embedding process. And essentially all data can be converted into these embeddings, which allows a common language. You can start to communicate from text to video or different data types. So AI kind of enables a more universal data state. So some examples, I use this, there's an algorithm called stable diffusion where it's like a text to image. So I just, this is open access. There's some subscriptions you can pay for, but I just did a basic example on the open access version, patient safety initiative. And here's the image it created. Kind of, humorous, it misspelled initiative, but, kind of made a reasonable image from text. And that's an example, again, of this unified data space where we're basically translating from text to image. Another example with an image on the left, that's a picture I took on vacation years ago. I put it into a model that would convert images to video, right? So pretty cool. You start with this still frame image, and from that you can get an animation. That's pretty high fidelity. The model also lets you accept text. So I put this image, the same image, plus the text, strong wind blowing the trees, and we have a sort of a different animation. So it's a cartoon example, but hopefully it gives you a little bit of appreciation that you can, again, combine data types that are very different structures using AI to get a kind of a different output. All right, so how do we think about language models? Lots of different schema. My preferred way to look at them is kind of two ways. One is a large versus a small language model, and that really talks about how many parameters are in the system. And then the second way is traditional versus generative. So there's a few example applications within each of these. So traditional, you do things like classification. So let's say I give a block of text to an algorithm and I say, tell me if this block of text is happy, sad, or neutral. That's a simple example of classification. Semantic search, that's where you're searching a database by intent rather than keywords. So if you search the term neuromuscular blocker, you may get succinylcholine, rocuronium, maybe you get Sugamidex, as opposed to old school search engines where you'd only get direct keyword hits. Generative AI, these are more of what you read in the literature these days, like chatbots, translation, summarization. You're actually trying to generate something, I won't say something new, but something, you're trying to create something that's a little bit different than the input. And we'll talk about a couple examples. So a little bit more about large language models. In general, anything more than a few billion parameter language model that size or bigger is a large language model. Examples, ChatGPT, the Llama series by Meta, and like Gemini by Google. Advantage of these, so performance for these models tends to scale with size, computational power, and the size of the training data. So this is a kind of a seminal paper published probably 7-8 years ago about scaling laws in language models. On the y-axis it's called loss. It's basically like the error of a model. So the lower the loss, the less the error, the better it performs. And they looked at 3 different features of training an algorithm. So the computational power, the amount of data, and the number of parameters. And as expected, as models got bigger, as data grew, performance improved. And this kind of set off kind of the arms race in AI. Kind of bigger is better, more data, more computational power. Secondly, as models get bigger, they start to demonstrate this phenomenon of emergent capabilities. This figure is from OpenAI's publication on GPT-2, which showed that at increasing sizes of the model, meaning more parameters, more complex models, ranging from 117 million parameters to 1.5 billion parameters, the models perform better at each of these tasks when the model wasn't even trained to do all of them, right? So the model started to do tasks that you never instructed it how to perform. And so these emergent capabilities, again, reignited that interest in kind of bigger is better. Some of the disadvantage, these are very expensive. Some of these take millions of dollars, several weeks to train. They're challenging to fine tune them to an end goal, to an end task. Very expensive. You may require a massive data center to run these. You can't just fit this on your phone. Because of that, there's issues with security. There's issues with latency, how long it takes the model to give you a response. So small language models, so on the flip side, these are less than a few billion parameters. Examples, BERT, that's a Google model from 2018. Most of the bigger companies, they have instances, they have versions of their models that are distilled to much smaller. So Tiny Llamas, Metas, and then Gemini Nano from Google. These generally are small enough where you can fit them on an edge device like a phone. Because you can do that, and they're smaller, they're a lot cheaper to train. Again, they can live on your device a lot faster, they're more secure, and then in general, they're a lot easier to fine tune. Disadvantages, if you don't perform extensive fine tuning, they may not be very good at whatever task you want to use it for. So it does require some, AI engineering to handle it. And you also don't see these emergent capabilities because they're just a lot smaller. They're just for one specific task. It's more of a technician, whereas a large language model is more of an expert. It's a good way to think about it. So let's look at a few quick examples. We'll wrap it up. So one example, information retrieval. So our goal here is let a user search by intent rather than keyword. And this is that semantic search I referenced earlier. The input is some question, the output is some mathematical representation, which then can be used to search a database. So in cartoon form, it looks like this. You put in a question to a pre-trained language model, you encode that into some mathematical space, you compare that encoding to your database that's already been encoded and saved, and you find the best matches. And therefore, you don't need to worry about keywords, you can find key concepts. This has been an area of focus for our target group. So as an example, in our database, here's just a quick example. I searched endocrine disorders, and these are the hits that came up. So endocrine anesthesia, parathyroid physiology, pair evaluation management, endocrine disorders, shifting paradigms in managing carcinoid syndrome. So you can see this is searching based off of like the concept of what is an endocrine issue, not just the keyword endocrine. A second example, feedback on communication, right? I'm a program director, I care a lot about this. It's hard to train and to teach and to measure communication. The idea is that, can we deliver metrics to a trainee on patient handoff accuracy, completeness, and conciseness without needing a teacher present? Can you do that with an AI system? So we worked with our residents to develop a bunch of mock patient handoffs. We fine-tuned a model to be able to identify key patient handoff elements within that model. So as an example, after we trained it, we put in this mock patient handoff, something you may tell somebody in the PACU about this 55-year-old ASA4 patient. This is what the model output. So identified that, 55-year-old was age and gender, ASA4 was the ASA class, did a pretty good job identifying the medical history and then what procedure was performed. So you can imagine you could build this into a larger system where, number one, you can improve communication, where you can have, this on a displayed on a smart board, kind of automatically, so you can make sure the communication is thorough and concise. But you can also build a system. You could build this into an app where a trainee, medical student, or resident practices their patient handoff over and over. They get feedback on how well their patient handoff hits certain metrics. Number one, accuracy and completeness. But number two, you could also measure how long they spoke, how many words they used, et cetera. So that over time, you can have some aggregate score with all their performance and ideally see that improve without ever needing another faculty anesthesiologist to do a whole lot of intervention. Third example, teaching emotional intelligence. This is a paper that came out, I think this month actually, in Anesthesiology. The group wanted to generate on-demand, challenging clinical scenarios to guide like interpersonal conflict or communication simulations. So as an example, they used this prompt. Here's this one example. They put this prompt in, create a role play script where there's an anesthesiologist who addresses conflicting priorities between two surgeons. Both surgeons are stressed. They want their case to proceed. And the output of the model was, hey, here's like essentially a play. Here's a script. Here are the characters. Here's the setting. And then here's the scenes with the different things that you can say back and forth. So a great starting point if you want to make some new curriculum on communication, have the language model generate a good starting point, and you yourself can personally titrate the specific scenario however you want it to play out. Finally, as we've been talking about with how do we integrate all these different pieces of data together, what does a final system look like? At the center here, we have the trainee where we're trying to personalize education delivery. As I mentioned, AI is really good at converting disparate data types into a common language. So again, we can take all these different pieces of data streams, stuff from the electronic health record, question bank performance, patient handoffs, OSCE performance, all sorts of things, put it into some sort of recommendation engine where we give people just-in-time education modules or vetted resources to help promote their growth. All right, thank you.
Okay, thanks, Dr. Booth. Now we're going to move to Dr. Kitana, who's going to talk to us about an actual PME app that's trying to be, well, it's in process of being developed.
Hi everyone, and thank you so much for joining us today. My name is Khaled Kitana, and in this part, I'll be talking about how we've been working on the development of a medical education app for anesthesia that provides personalized content for its users. I have no financial relationships to disclose. To get started, let me outline the problem that we're trying to solve. One of the major challenges in medical education is getting the right information to the right learner at exactly the right time. Many digital platforms provide access to vast content, but they often feel static and do not adapt well to the learner's evolving needs. This creates a gap between what learners have and what they actually need in their practice. And so our solution was to design a learning experience that feels familiar and intuitive. We wanted to produce an app that felt much like a social media feed. Instead of scrolling through a news feed, learners would scroll through a learning feed, where they see recommended educational content. And much like social media, the content would be individualized to each learner. We also wanted to have a low-friction interface, something that is easy to use so that it acts as a companion for the learners throughout their journey. And finally, we wanted to include stakeholders like residents and attendings in the design process. We start with getting the right content. Internet resources like YouTube, ChatGPT, or even Google are accessible, but they often lack the depth and quality needed for professional medical education. In building this app, we wanted to make sure that learners receive high-quality, reliable educational content. To do this, we carefully selected and reviewed material from a range of trusted resources. We also engaged specialty society education committees like SOAP, Trauma Anesthesia Society, SNAC, and the Society of Head and Neck Anesthesia to help us identify the best resources in their field. Finally, we wanted to accommodate learners' preferences, so we included multiple formats like articles, podcasts, and videos, so that learners can engage with the material in the way that works best for them. Altogether, this approach gives our app a significant advantage compared to a simple online search. Of course, content alone isn't enough. As Dr. Hollon and Dr. Gopawani emphasized, data about learner is key to personalization. For us, the starting point was to focus on the low-hanging fruit, the data that is most readily available to us. First, we could assess learners' knowledge through their quiz bank performances, which helps us identify what concepts learners know and which ones they don't. Second, we could use competency assessments from My Tip report, which show us what skills learners are competent in and where they still need some improvement. And third, we could estimate learners' experience from the EHR. So, for example, we can see how many times a learner has provided anesthesia for a certain type of a surgical case, how many times they've placed an arterial line or a nerve block, or how many times they've encountered a patient with aortic stenosis. All these are concrete measures of clinical exposure. These three items could provide a strong foundation to personalize the learning feed so that each learner gets content that is relevant to their needs. When presenting educational recommendations in a list, it is important to order or prioritize the list properly, as users often only view the first few items in the list. Our intent is to utilize the information about learners' knowledge, competencies, and experience to prioritize items in the learning feed. Our goal is to present the items most useful to the learner at the beginning of the list. Similarly, context of the learner matters when prioritizing recommended content. For example, if a learner is on their OB rotation, then OB content should be prioritized. Also, clinical outcomes are a special form of context. When a learner experiences a less than optimal outcome or an adverse outcome, this is a unique opportunity to present the learner with content recommendations related to that outcome, particularly if the outcome is identified in the same or the next day. All these factors can be important in ensuring that the learner is presented with the right information at the right time. Another form of context is what surgical procedures a learner will be involved with the following day and what medical conditions these patients have. That's why we've built a feature that connects with the EHR, showing the scheduled clinical encounters. The learner can easily access content related to these encounters. Note that the content is also prioritized based on the learner's knowledge, competency, and experience. In the example that we have here, the resident is scheduled to do a cesarean section at 7:30 in the morning, and the patient has obstructive sleep apnea and pulmonary hypertension. So the app will trigger content based on that information. To make sure that the design truly fits into what users envision, we ran multiple focus groups with residents and attendings. We explored how they interpreted interface elements like icons and buttons, how easily they could navigate the interface. We also asked for their input on new features they thought would be helpful in the app. We then met with the design team to review these ideas and set priorities for the ones that will have the biggest impact. Based on the feedback that we got, here is a look on how the app will look like. On the first screen, you can see the main menu of the app. Learners can navigate through their learning feed, the cases, or items they have viewed or saved for later. As we said, the goal is to make the navigation intuitive and low friction. On the second screen, you can see the learning feed, which is like the social media feed. This is where learners receive recommended content, and each item will show details like the title, the time, and could be expanded for more information. The third screen shows how learners could apply filters according to their preferences. And finally, the fourth screen demonstrates how learners can interact with the content. So far, we've built a functioning app with over 3,200 curated items. This app has basic features like library, favorites, save for later, or recently viewed. We've also started experimenting with large language models to map clinical cases and conditions directly to the relevant content. Looking ahead, our main challenge is securing sustainable funds, and that's the biggest bottleneck to moving the development forward. Our plan is to start with App Lite, a simple version that includes the essential features and can capture user interactions to help us train our recommender system. Then, we'll expand into App Heavy, the full platform with deeper integration. It will have epic experience data, competency assessment from MyTip report, and potentially quiz bank data. Thank you so much for your time.
Thank you to all of our panelists to talk with us today about precision medical education. And I see I've got a couple of questions in the chat, and I remind everyone to use the QA button at the bottom of your screen if you want to enter some questions. But let's go ahead and start with a question posed by Dr. Diashin, and essentially she's talking about if we are using some method of artificial intelligence to provide coaching to the learners and help them identify gaps and say what you got to do, does that in some way impair their ability to do self-assessment? And so I think I'm not sure we have an answer to this question, but I'm going to go ahead and I'm going to ask Dr. Hollon to address that question.
Sorry, Glenn, I can't see the question in the chat. Could you
Yeah, but basically the question, I'll read it out to you. Does the use of an automated coach that gives a learner their learning gaps and tells them what to learn next, does that impair the learner's reflective process?
So, of course, there's no way to say absolutely not, this doesn't impair the learner's process. But the idea with using technology, especially educational technology tools, is that they enhance the role of the teacher. They enhance the ability of the teacher to reach the student. So the technology would guide the teacher perhaps in what gaps the student has, or perhaps provide some educational materials, or direct them to any other resources. But no, we don't envision that technology replaces teachers.
I guess really the question to me is more that Dr. Daishan has raised is more about the learner's own self-reflective process. I think the issue is everybody's heard the comment, you don't know what you don't know. And so in some ways, learners' reflective process is not very accurate about what their competencies are, where their knowledge gaps are. And that has been shown in the literature that they're not very good at their self-reflective process. And we'd like to improve that, but I don't think there's any literature on whether automated coaches would impair improving their ability about their self-reflective process. But that's a really interesting question. It'll be interesting to see how this plays out. I'd like to move to another question, and this one is posed by John Rowlingson. And his question is if there is missing data, is there a risk that an AI system would make it up? I think this, we all are familiar with things, in the popular culture right now about artificial intelligence models hallucinating. And I don't know if Dr. Booth might be able to address that a little bit in the context of precision education.
Yeah, thank you for that question. The way that we are trying to conceptualize this is the app has what we call triggers. So an AI model wouldn't necessarily run unless it was triggered to do so. And a trigger would be something like there's a new case assignment, there's a new clinical note that's pertinent to your education, there's a new question bank question that you performed. So generally, the only time there's an AI model running is when there's a trigger that says, hey, run this data and do something with it. So that's the first piece. So I don't think there's as much risk of like running AI in some void of information. The other issue is that, I'm a strong believer that I'm skeptical of any AI system. And so I never use them to make a decision. The whole role I feel with AI is to use that to free up your bandwidth to do more important things. And the most common target is to organize data. So I wouldn't use a precision medicine education AI application that like makes a decision on their competency or their progress through training. Instead, I would just use it to feed information to them or to say, hey, maybe take a look at this. You're not maybe as performing as well here. That way the stakes are not as high. So if it were to hallucinate, if it were to misbehave, the stakes are not as great.
Dr. Booth, I'm going to kind of elaborate on that question a little bit. The first is, let's say you had an AI system and you put in a prompt like you did before on endocrine systems, and let's say the content that you were drawing from didn't have very much information on endocrine type content. What is the risk of the system essentially trying to make it up, of this hallucinate data in that area?
Yeah, so certainly you could get like so that's the example information retrieval. You could get hits that are not very good, not very high quality. I think the biggest risk is people who kind of stop using it because it just doesn't give quality results. Um, as far as like, does it misguide people? I mean, I think that's pretty low risk, especially in the education realm where we're not necessarily talking about asking questions that have serious consequences for patient management, for example. I think the worst risk is it just kind of is frustrating to use, and you have to go to a separate source to get the good information that you need.
Okay, and I wanted to follow up on another area that you discussed about sort of structured and unstructured data. So the old folks like myself remember where, everything was in a paper record, and there was no value to the information. It was very difficult to extract information. And then I would say we moved into the area of drop-down boxes where every time we had to put a piece of data in, I had to select what block it is and what level I put the thing in and how much you basically had to fill in all of those structured data elements so that then analytic processes could be used on that data. I think that's probably the era of the last 10 to 15 years of computing. But now with the ability of language models to interpret unstructured text, it's possible that what I'm hearing you say is that we don't need as much of the structure in the data anymore. It would be possible for a language model to just look at a unstructured procedure note on a regional anesthesia block, and from that be able to derive information that would be available for analysis. Is that correct, Dr. Booth?
Yeah, absolutely. There's been several studies in the last year or so where that's been done. I've seen a couple with GPT-4, a really big language model. I think it's got 1.8 trillion parameters. These like emergent, very strong capabilities, and this that comes to mind. They did a few different they fed it radiology notes, they fed it patient progress notes, and a couple others, and they basically asked it, hey, summarize these or tell me what is the diagnosis or what is the relevant past medical history elements, and it did very well. It performed in their analysis better than humans on almost every aspect. So absolutely, that's where the value is. Again, I think it's like organizing the data so that you can make a better decision and focus on the more human aspects of whatever task you want to perform.
Awesome. And then also you mentioned a couple of things about how language models are useful for classification. And I'll just point out one area that we're currently working on related to Dr. Diashan's issue about coaching, which is, can we analyze faculty feedback and look at the faculty narrative feedback that's provided in written competency assessments, and then look at that data and try to be able to classify it in terms of quality on various quality domains, and then give feedback to the faculty member and maybe coaching on how to improve their narrative feedback. So that's one area that we're working in. Now, Dr. Rollingson has another question, which I think is a little bit more technical, and see if you can dumb this down for the rest of us to understand. But he wants to know, what are the hazards of embedding, quote unquote, embedding data using the language models? And of course, that goes to Dr. Booth.
Yeah, so hazards of embedding data. Well, certainly hallucinations, right? That's kind of what we're seeing, you know, that's a big issue with language models. I mean, that's the biggest one that comes to mind. You know, incorrect answers, models that don't perform as you expect. The embedding process depends entirely on how the model was trained. So if you had a model that was trained on some variety of language, let's say like the BERT model that was originally trained mostly on like 10,000 like literature books, and then you apply that to like scientific realm, healthcare realm, the embeddings would be more aligned with like classic literature than would be with you know, scientific literature. So you know, I suppose it depends on the application. If you're trying to take one model and apply it to a different realm, there's a risk that just is way off. And then the other risk is hallucinations, I would say. But that's part of the kind of quality control when you build a model is you try to break it. You try to give it a bunch of adverse inputs to see how it behaves. And if it misbehaves, then you go back to the training, you retrain it, or you put some post-processing safeguards on it to, you know, decrease you know, whatever negative outputs that you're seeing.
Well, I don't want poor Dr. Booth to have to dominate all of the panel questions, but not surprisingly, a lot of the questions are related to artificial intelligence and the use of artificial intelligence. And several questions are related to essentially information security. So I'm going to pose the question to you, Dr. Booth. If you are using a model and let's say you did upload some information out of a medical record and you wanted it to analyze it, what are the security issues, HIPAA issues? You know, how does that play if you want to use a language model to analyze clinical data or even learner data?
Yeah, so you definitely don't want to put data into like a public facing language model because you just don't have control over it. So a lot of these studies were done at universities that have licenses with like OpenAI, for example, where they have their own protected instance. And, you know, sometimes that runs on a data center that the university owns. So it basically comes down to having some sort of licensing agreement infrastructure where you know that data lives. Either the best way to do it is we call an air gap. So it's a device, like some sort of device computer network that's totally disconnected from the internet, right? That'd be the best. The second best is some sort of licensing agreement where a company with, you know, very smart IT folks ensures that the data lives within that protected, you know, sort of legal infrastructure. But you certainly don't want to just throw data out there into like an open access model.
Unfortunately, I suspect a lot of people are putting clinical data into open access models. But if you had one of those, you know, instances where you're licensing it for your institution, it's completely contained within my institution, then am I allowed to put HIPAA data into that system? Is it a business associate? How do you think that might work?
Yeah, I don't know. I'm not qualified, I think, to answer that. I would just consult with your institution, leadership, legal folks, things like that. And that's probably why I've personally focused on more the small language models, because you can have those on, you know, a very secure device that doesn't require some external, you know, data warehouse, for example, or you know, computational abilities outside of your institution.
All right, I'm going to change to a different panelist, Dr. Gopawani. Do you think you could just explain a little bit about what you meant about the difficulty of dealing with time constants? So let's just take something simple like your competency on placing an arterial line and how that might change over time. Can you tell us a little bit about the difficulty of analyzing that data?
Yeah, sure. Thanks. So, you know, we could look at data and see how many arterial lines a resident or a trainee has placed, and we might get a raw number like 5 or 10, and that may be valuable to assess their competency. But that 10 can mean something very different, right? We could have a resident who did 10 arterial lines a year ago, and then another resident who did 3 a year ago and 7 in the last month. And this could be true for any sort of knowledge, experience, or skill assessment. So the question really becomes, when we take that data, how do we assess that, like that sort of time constant? Do we take, for example, do we evaluate how much a resident has done in the past 6 months or 3 months? Or do we, and how do we compare that to their cumulative experience? In addition to getting the data, this assessment over time is sort of critical to how we direct content to them and how we assess them.
Right, I think I see some people putting things into the chat, but I was actually only monitoring the Q&A action. So you have to hit that little Q&A button for it to go in. We're also at 2 o'clock, and so I don't know if let Tracy if she wants us to continue to answer questions, but I'm certainly available. But one question here from Kristen Howard to the panelist is, does the use of a chatbot coach that gives a learner
No, that was actually a repeat, just so that Dr. Hollon.
Oh, just repeat it. You put it into there. Yeah. As I started to read it, I go, wait, this sounds familiar. Okay, well, I'll just finish off with a comment related to Dr. Gopawani. Baseball has tried to deal with this issue of time constant of data. So, for example, if you look at your batting average, if you've had 1,000 at bats and 50% of the time you're able to, get a hit, your batting average is 50%. But on that 1,001st time, and let's say the next 3 times, 1,001, 1,002, and 1,003, you all get a hit. Well, you're on a streak, man. You're doing really well. But your batting average, because you've already got 1,000 data points, is very unlikely to change. So competency systems, assessment systems, and knowledge systems are all trying to figure out how to manage that time constant. What is your competency today in the last week, as best as we can tell, versus what is your competency, over the complete time of your residency. Now, because we are at 2 o'clock, I want to thank all of our panelists for a very interesting presentation on what is precision medical education, what are some of the challenges with data, how can we use AI in precision education, and what a current precision education effort looks like. So thanks to everybody for participating. I'm going to stay on just in case there are any other questions until Tracy terminates us. Okay, so thanks very much. Got another question here, but it's a little bit difficult to answer, I think, and I'm sure Dr. Booth will struggle with this, but how do we test the reliability issue of AI on clinical decisions and issues of misleading AI-based decisions? So I'm gonna take this one myself partly, and then I'll throw it back to Dr. Booth. Let's say I'm not going to do something like on something as high stakes as something as competency, but let's say something as simple as I wanted to rate the quality of this narrative feedback. So how good is this feedback? And I could have a bunch of experts perform ratings on it. I could have the AI perform the exact same, using the same domains, also provide rating. And then there are statistical methods called inter-rater reliability is the most common one, where you could test the performance and report out the performance of AI against experts. So I don't know if that answers your question, but that's how a lot of systems work, is that they test the performance of the AI against quote unquote experts. Dr. Booth, do you want to add anything to what I said there?
No, I think that's a reasonable answer. A lot of times there's ongoing, any good AI system has ongoing quality control validation built into it. And there's a lot of different ways that you can do that, but generally comparing your outputs to some validation test set, and then you have some acceptable error rate or that you can kind of monitor over time. As far as misleading AI-based decisions, again, most AI systems now, I think the utility is really a sort of a decision. It like kind of helps you make the decision. It kind of leads you to like maybe organizing the data so you can make the decision. We're not really using it to make decisions, especially like Glenn said, high stakes things like competency. Um,
Well,
so it's
they are using AI to sort of make decisions. So, for example, on diagnosing a chest X-ray, for example, and comparing how good an AI model is about examining an X-ray and reporting out findings compared to a human. So I think there are clinical decisions like that are being made by artificial intelligence systems, and they are testing them against human accuracy, some where it's below, some where it's better. But I think this is an emerging field, and before, particularly with generative things, generative AI, it's very, very challenging sometimes in those cases to test the quality. But that's going to be something that's going to be happening over the next several years. I think that's going to be a big push before, we have to have evidence-based medicine, right? And AI is a tool like any other tool. So what is the evidence that this particular tool performs better or helps me in some way? So I think that's an important thing.
Yeah, I guess I should
Carol,
clarify.
go ahead.
I was just going to clarify. I guess I was speaking to using AI in precision medical education. I guess no decision making within our realm, but you are right. You can read several examples in the literature. Examples of using an AI system to decide who to interview versus not. That was a big one where they were very biased. Only selecting a subgroup of people to interview and being very discriminatory. So that is absolutely a big issue that is definitely not solved.
Yeah. Dr. Dyshans asked another question, and Greg, you're perfectly suited to answer this because you actually wrote a paper on this, which is the ability of using language models to use a rubric and identify milestones and a milestone level reached by a learner based on narrative feedback. So that can be tested against the Clinical Competency Committee or other experts on rating milestones. Do you care to comment on that?
Sure. Yeah. So the work that we did was basically looking at a bunch of resident evaluations and having a group of experts assign a milestone to them, which milestone, which sub-competency best applied, and then training an AI system to basically emulate that behavior. It's pretty interesting that in the development phase, we had two experts review every evaluation, and there was really high disagreement for many of the sub-competencies, especially when you start getting down to professionalism, communication, system-based practice. The inter-rater reliability was very poor for a lot of those. So using AI to map feedback to the milestones, our model worked pretty well, like across most of the competencies where there was like reasonable rater agreement. It was an area under the curve, 0.7, 0.8, and even over 0.9 for a few of them, especially the patient care ones, which is really easy. It's easy for a system to know if an evaluation is speaking towards airway management or vascular access. That's pretty straightforward. We don't use the system to make decisions. So, we haven't done that second part of your question where you're testing the model decision against CCC decisions. We try to use it to organize feedback so the CCC has like a very nicely structured format where it's like, hey, this is all the narrative comments organized competency. So that, our CCC rubric will say, for patient care 6, we're going to look at maybe some of their rotation experiences plus the comments. And so that second step plus the comments doesn't require you to read everything. You just read the snippet that applies.
Yeah, I don't know if it's been done. I don't believe, I'm not aware of any literature, perhaps you are, about where people have taken, let's say, a year's worth of competency assessments filed on a trainee and then said, okay, this is where I think they are on all these different milestones, having the AI do that, and then comparing it to what the CCC actually reported out.
Yeah.
I don't think that's been done yet. Yeah.
Yeah, I feel like as a program director, there's no way. It's so hard to get a nice distribution of comments for any milestone, let alone for all of them. It would have to be a well-designed study where people got very detailed, extensive feedback all the time, I think, to have enough data to do that.
Well, thank you to all of our panelists. It was a great discussion, and thank you so much. I think we're now a little bit over time, so I think we'll wrap this up. Again, I want to remind everybody that you can access the IARS webinars on the IARS website, and I encourage you all to attend the meeting in Montreal in 2026. So thanks to all our panelists. Thank you so much.